Good afternoon, students. So next experiment is experiment number 3. So here in this experiment we'll see that the measurement of angle of a given specimen using sine bar. So what are the apparatus are required? Sine bar, height gauge, vernier caliper, surface plate, and a specimen is going to be required here. So here, what do you mean by sine bar? So why this sine bar is going to be used? So this sine bar is going to be used to measure the angle accurately as for the locating any work to given angle within the limits of that sine bar are going to be used. So this sine bar is going to be made up of a high carbon steels, right? And this sine bar also made up of high chromium and corrosion resistant steel that is going to be hardened, ground and stabilized to cylinder of equal diameter are attached to the end of that sine bar. So here this distance of this cylinder is 100 mm. So the known angle is calculated by using. So how to calculate the angle of the given component? So here we are having one formula. So that is sine bar is equal to, that is nothing but theta is equal to h divided by L, right? So here you see that sine theta is equal to h2 minus h1 divided by L, or theta is equal to sine inverse of h2 minus h1 divided by L, right? So here where h is the height of slip gauge, L is the distance between the center, and theta will be the angle of work to be measured. And here the procedure how to measure the angle of a given component. So first you have to put the standard workpiece on the surface of the sine bar. On the sine bar you should have to place the workpiece, right? Then place the slip gauges below the rollers. There are two rollers are there in the sine bar. So below that one you should have to place the slip gauges. Next you should have to check the parallelity by using the spiritual level. By using that spiritual level you should have to check the parallelity from the base to the measuring surface, that is parallel or not. After that you should have to assume that workpiece is parallel. Then you should have to calculate the angle by using that formula. That formula is nothing but sine bar, that is sine theta is equal to h by L. So here you should have to know the value of what is h2 and h1 divided by L. Before starting or before conduction of this experiment, you should have to do some observations of sine bar. First you should have to know that least count of height gauge. Second point is height of smaller end, that is h1. Third one, height of larger end, that is h2. Then fourth one is what is the length of specimen, that is L is equal to. Fifth one, theoretical value of angle theta 1 is equal to sine inverse of h2 minus h1 divided by L. Sixth one, length of sine bar, that is L. Seventh one, height of lower roller, that is h1. Eighth one, height of upper roller, h2. Next, practical or actual value of angle theta 2, you say sine inverse of h2 minus h1 divided by L. So these are the some observations you should have to make before conducting the experiments, right? So now we'll see the observations, that is what is the least count of height gauge, height of smaller end, height of larger end, and what is the length of specimen L. So from this one we are going to be getting the theoretical value of theta 1. So after that we should have to see the practical values by seeing these observations, right? So next we will conduct the experiment.